This week we get to learn about titration curves. You need to be able to sketch a graph of an acid-base titration curve if you are given what type of substance is in the Erlenmeyer flask, what is your analyte, and if you're given what type of substance is your titrant in your burette. You also need to be able to determine the type of titration occurring if you are given the graph. So if I show you a picture of a graph, you should be able to look at it and determine if you have a strong acid with a strong base, or a weak acid with a strong base, or any of the other variations. You also need to be able to figure out what the equivalence point is, both the volume of the equivalence point and the pH of the equivalence point. You need to be able to pick an indicator based on the graph. So when we find the equivalence point, we will then choose an indicator that will change color right around that equivalence point. So then we would know when to stop our titration if we weren't doing a titration curve. Finally, you should be able to use a graph to get the information you need to perform a stoichiometric calculation. In creating a pH curve, the titrant is added slowly and a pH reading is constantly taken, and the titrant is not stopped at an endpoint like we do in a typical titration. It is added until there is a large excess that has been added to the solution. So we see a pH change through the whole spectrum. A very rapid change in pH occurs at the equivalence point. The equivalence point is when there is equal amounts of acid and base. Indicators show this point by changing colors, and we call this the endpoint of a titration because that was where we would typically stop our titration. The endpoint is when we have a color change. So here we have an acid-base titration curve simulator. I've already run it once and you can see what the curve looks like. We're going to retitrate with the same settings. Now, in order to get this curve, I'm going to start, my pH is 0.3, I'm going to add some base. Now 1 milliliter of sodium hydroxide, all of it was neutralized by the acid and not a significant amount of acid has changed, so the pH hasn't changed. I'm going to add another milliliter. Now we have a slight change in pH, but really not much is happening. I'm going to add some more really quickly, and you can see the pH is increasing, but not really that much. So the acid is neutralizing the base and it's continuing to maintain its acidic properties. So we are in what we call the buffer region here. Now, because my curve has started to show a slight increase in slope, I am going to add a little bit more slowly some base. And we can see that it's getting very, very steep. So let's add even more slowly some base and see what happens to my indicator color. I have now hit a pH of right around 7, and my indicator has turned from yellow to a greeny blue color. Now, that would probably be my equivalence point, but let's add one more 0.05 milliliter and see what happens. And now my pH is way up here at 10.7, and my color is now blue. This shows me that I have now neutralized all of my acid, and the hydroxide that is present, because bromothiamyl blue will be blue when there's excess hydroxide, the hydroxide that is present is now the dominant species. I'll add a few more 0.05 milliliters, and now I can add 0.10 milliliters, and now my base is the dominant species, and I'll go a little bit faster. We are going to finish our titration curve. So we have created this nice curve and we have a very sharp inflection. If we were to draw a line on these points, which is what often acid-base titration curves have, they have a line of best fit that follows these points, you would see the steepest point and the middle of the steepest point. That is our equivalence point. And here it's at 7 and it's at 25 milliliters. Now that we've seen how pH curves are created, you should be able to look at these and understand kind of what's happening. So if we start at a pH of 0 or very close to 0 down here, right, we know that we must have a strong acid that is present, and we see the buffer region right here, and then we see this very steep inflection point here. This is the steepest part of the graph, and we try and find the middle of the steepest portion of the graph, and we follow that across to find the pH at the equivalence point. We also want to be able to find the volume at the equivalence point, because that will help me in my stoichiometric calculations. Now that I know what my pH and volume is at my equivalence point, I would continue to do my titration curve and see where the pH finishes, and we see the pH finishing way up here around 14, so I must be titrating with a strong base. The title of this curve would be the titration of what's in the Erlenmeyer flask, a strong acid, with what's in the burette, a strong base. A couple other things to notice when we are titrating a weak acid or a weak base, we will see a sharp little inflection at the start of our titration before we hit the buffer region. So there's a sharp inflection, and then we hit this buffer region that's in yellow. And then we'll have the inflection point, which will show us in the middle our equivalence point, and our pH will be approximately 9 to 10, depending on the type of weak acid. For each of these curves, try and title the graph, just like I did, titration of a whatever it is with a whatever it is. And choose an appropriate indicator by looking at the back of your periodic table for the indicator color change ranges. You want to choose an indicator that changes somewhere in that steepest inflection.